State Dalton's atomic theory. Question says that matter, the first theory, Dalton's have four fundamental theory, right? Four fundamental theory. The first one says matter consists of indivisible particle called what? Called atom. All matter consists of indivisible particle called atom. That's the first one. Number two is that atom can neither be created nor what? Destroyed. Atom cannot be created nor destroyed. The third one says that atoms of the same element are alike in all aspects, but differs from atom of other elements. Atoms of the same elements are alike in all aspects, but differs from atom of other elements. Is that clear? Okay. The fourth one says atom combine a small whole number when they form compounds. Atom combine a small whole number when they form what? Compounds. Okay, the next question we'll look at now is that we should state 5 properties of cathode ray. Cathode ray. 5 properties of cathode ray. The first one is that cathode ray travels in a straight line from cathode to the anode. They travel in a straight line from cathode to the anode. Cathode rays are negatively charged, meaning they are electrons. Cathode rays are negatively charged, which indicate that they are what? Electrons. They possess kinetic energy. Since they travel in a straight line, that means they possess kinetic energy and can exert mechanical pressure. Cathode rays are deflected by electric and magnetic field. They are deflected by electric and magnetic field. Since they are negatively charged, that means they will be attracted towards the positive plates of electromagnetic field. Cathode rays, they produce fluorescence when they strike certain metals like glass or phosphor. When they strike certain metal like glass or phosphor, okay, they will always produce what we call fluorescence. The next question we'll look at says, we are given a table and we are asked to complete the table. Given a table, let me quickly draw the table. Here we have the elements. Here we have number of electrons. Here we have number of protons. Then we have the last column, which is, okay, the element we have here, element X. Here we have 238 and 92. Here we have Y, 235, 92. Here we have Z is 208 and here is 84. Listen, every element are always symbolized in this form. Here we have A and we have Z, where A represents the mass number, alright? Then Z represents the atomic number. The atomic what? Number. Mass number, don't forget, is the sum of proton plus neutron. Okay, mass number means sum of proton plus what? Plus neutron. Alright, so mass number simply means number of proton plus neutron. We call this the nucleon. Right? Nucleon means the sum of proton and neutron is called a nucleon, right? Okay, so the next is atomic number is same as number of electron and also number of what? Proton. Number of proton is number of atomic number means number of electrons and proton. Now here we are asked to find, to fill up this table, number of electron. A represents mass number, Z is atomic number. So anything we have here represents the mass number. This is called the atomic number is same as what? Number of electron and number of proton. So that means here we have 92. Alright? Okay, so for this number of neutron, I'm going to subtract this 238 mass number minus number of proton equals number of what? Neutron. Alright, so to get, since proton plus neutron equals to mass number, so that means mass number, to solve for number of neutron, I have to subtract proton from mass number. So when you subtract these two, that will give us about 146. Okay, let's proceed with this. Here we have 92 as well. Here 92. Then we're going to have 143 here. When you subtract 235 minus 92, that will give us 143. Then here we have 208, 84. So here 84. 208 minus 84 will give us about 124. So this is just how to fill up this table. The next question says, define the term activation energy. How you guys are following? Define the terms. Activation energy is defined as the minimum amount of energy required for a chemical reaction to occur. It is the minimum amount of energy needed for a reaction to occur. The symbol is represented as this. According to Arrhenius Equation, Arrhenius gave us a relationship between temperature and rate constant. According to Arrhenius, that rate constant is equals to A exponential minus EA divided by what? LT. This is Arrhenius expression to find activation energy. All right. Okay, I'm not going to explain all of these terms, but from this expression here, we are going to derive a formula that can be used to find activation energy. All right. I don't think they will ask you to derive such formula, but just know that the relationship between rate constant and temperature, according to Arrhenius, how temperature is affected by the rate constant, or how they are connected, is that K is equals to AE minus EA over what? Then activation energy EA can be calculated. By the time I take natural logarithm of both sides, we're going to have a formula like this: log K2 over what? K1 equals to EA over 2.303 R, the times T2 minus T1 over T1 times T2. So from here, we can actually make our activation energy to stand alone as the subject of the formula that we can calculate for our EA. So there's a question here that says that, let's get the question and solve together. Sorry. Excuse me. Okay. The rate of reaction triples from increasing the temperature from 290 Kelvin to 300 Kelvin. Find activation energy. The rate of reaction triples from increasing the temperature from 290 Kelvin to 300 Kelvin. Find activation energy. This formula is connecting two different temperatures. When you increase your temperature from 290 to 300 Kelvin, what is the impact of that increase on activation energy? What is the impact of that increase on activation energy? So the formula says that log K2 over what? K1. K2 is for the second temperature. K1 is for the first temperature. Now, are you getting it? So for the first temperature, 290, the rate constant is K1. All right. So if they say the rate of reaction triples from 290 to what? To 300, that implies that the ratio of K2 over K1 is what? Is 3. Triple means 3. All right. That means the ratio of K2 to K1 is 1 is 3. If the question comes this year and says the rate of reaction doubles, means K2 over K1 is what? Is equals to 2. Or if the rate of reaction increased by a factor of 4, that means K2 over K1 must be equals to 4. Alright, so what do we do here is, since we already know that our K2 over K1 is 3, our T1 is 290, our T2 is what? Is 300. So all we need to do is to substitute the value. So we have log K2 over K2 is 3, all in base 10, don't forget, all equals to EA divided by 2.303 times our gas constant R is about 8.314. 8.314. You will always be given this, but in case you're not given, please take note that gas constant is what? 8.314. Alright? So multiply with T2 is 300 minus 290 divided by 290 times 300. So let's see what we are going to have at the end of the day. Okay, after cleaning here, let's see what we're going to have at the end of the day. Log 3 in base 10 is about 0 points. Please verify for me. Alright, all equals to our EA divided by 2.303 times 8.314 is about 19.147. Alright, all multiply with 300 minus 290 is about 10 divided by 290 times 300. That will give us about, let's verify, I guess 27,000. Excuse me. Let's verify the answer. Okay, 87,000, right? 87,000. Okay. So, but at the time we multiply that, the next is to evaluate further. Excuse me. 290 times 300, 87,000. Okay, we are correct. So, evaluating further, we're going to have 0.4771 equals to EA divided by 19.147. Divide this with this, 10 divided by answer, we have about 0 points, okay, 0 points, right? So by the time we multiply this out, that implies that our EA is going to give us about, or multiply this with this, right? 0.4771, alright, times 19.147, all divided by 0. Alright, so I think this should be our evaluation. Let's verify. 0 points times 19.1 divided by 0 points. Sorry, this came out as add, but this add 0.47 times 19 points divided by 0.0001149. This is about our EA here is about 79. 2097. Alright, so 2097, this is joule per mole. So we can convert this to kilojoule per mole. In kilojoule per mole, we divide 2 by 1000, right? So our EA can also be approximated as 79.5 kilojoule per watt per mole. Alright, when divided by 1000, that will give us 1, 2, 3. So 79.5 kilojoule per mole. Alright, so let's see, the next question says that the light emitted by hydrogen atom has a wavelength of 81.5 nanometer. The light emitted, question 3, the light emitted by hydrogen atom has a wavelength of 81 nanometer. Okay, what is the frequency? We have to find the frequency. Number 2, find the wave number. And number 3, find the energy of the light emitted by the hydrogen atom. And we are given that our Planck's constant is 6.626 times 10 to the power of minus 34 joules second. This was given to us, and that the speed of light is 2.998 times 10 to the power of 8 meter per second. This was given to us. These two constants were given to us, the Planck's constant and the speed of light, and we have to find this. Now the first thing is to convert these equivalents from nanometer to what? To meter. Alright, that's the first thing we need to do. And to convert from nanometer to, nano means 9. This will give us about 81.5 times 10 to the power of minus 9 meter, right? Okay, so after converting that, don't forget that the word nano is minus 9, right? The word micro is minus 6. The word milli is 7 by minus 3, alright? So we have the word pico. We have pico is 10 to the power of minus 12. We have Armstrong. The symbol is A, which is 10 to the power what? Minus 10. All of these are conversions, don't forget. So if I have 1 nanometer is 10 to the power of minus 9. So if I have 81.5 nanometer, that means 81.5 times 10 to the power of what? Minus 9 meter. That's the conversion there. So let's quickly find this. And we have to find, the first one says find the frequency, right? Just recall that speed of light equals to what? F lambda, right? F lambda. Speed of light equals to F lambda. So to find the frequency becomes the speed of light divided by lambda. That will give us speed of light is given as 2.98 times 10 to the power of minus the power of 8 rather. Power of 8 divided by our lambda is 81.5 times 10 to the power of minus 9. So what we do is to divide 2.98 by 81.5. This will give us our frequency as, when we divide these two, we're going to have 3.68 times 10 to the power of 15 hertz. Number 2 says find wave number. In some textbooks they use n to represent it, or they use this symbol to represent wave number. Alright, so wave number means 1 over lambda. So that means 1 divided by lambda is given at 81.5 times 10 to the power of minus 9. Right, so our wave becomes, divide 1 by 81.5. When you divide, I have to move this minus 9 up, and it becomes plus. That will give us about 1.23. Please evaluate further. 1.23 times 10 to the power of 7 per meter. Yeah, because 1 over lambda, 1 over meter. The unit of wave number becomes per meter, because dimension for unit of 1 is 1. Unit of lambda is what? Is in meter. So this is same as meter to the power of minus 1. So per meter. That's the units here. Now the next one says find the energy. The third one says find the energy is equal to what? HF. So energy becomes, our Planck's constant is 6.626 times 10 to the power of minus what? 34 times our frequency is this, which is 3.68 times 10 to the power of 15. Right? To the power of 15. So what do we do? Is to multiply 6.62 by 6 points. This is about 24 points. Let's verify again. 6.6, right? 6.626. How do we get that? 6.626 times 3 points. 24.38. Yeah. Times 10 to the power of minus 34. Okay, let's go again. 34 minus 15. Raised power minus 19. This minus 19, right? Joule. So the proper way is I move my point this way. So our energy becomes what here? 2.4 times 10 to the power of, when we move our point once, it means I'm adding 1 to minus 19. The power becomes minus what? 18 joules. So take note of this.